Okay, for number 19, we now have polynomial numerator and denominators. So before I can see what my LCD or my common denominator is, I have to put these two denominators in factored form. So that's what I'm going to do first here. For this one I have x plus 1 over, and I'm here looking for what multiplies to 1 and adds to negative 2, which is negative 1 and negative 1. So that's x minus 1 times x minus 1. Minus, that's x minus 4. That's a difference of 2 squares, so that factors to x plus 1 times x minus 1. Now remember, the rule for your common denominator is you have to use every factor you have, and you have to use it the highest number of times you see it in either denominator. And that means I have x minus 1 in my first fraction as my denominator twice, so my LCD is going to have x minus 1 twice. I go to my second denominator, I already see an x minus 1 right here. I don't need to use it again because I already used it, and so I have left the x plus 1, and that's my LCD, x minus 1 squared times the quantity x plus 1. You can write the x minus 1 twice if that helps you to see later if you have anything that you can cancel. So now I have to look at my first fraction and determine what's missing in my denominator. Well, what's missing is the x plus 1. I didn't leave myself a lot of space here, so I need to multiply the top and the bottom of this by x plus 1. And that, if I'm multiplying by x plus 1 over x plus 1, I haven't changed the value. When I look at the second one, what's missing is one of those x minus 1's, so I have to multiply the top and bottom by x minus 1. I'm going to put parentheses around these so that you can see what I have there. So now I have x minus 1 twice times x plus 1 in each of my denominators, and now I add my numerators. So I have x plus 1 times x plus 1 minus x minus 4 times x minus 1 over my common denominator of x minus 1 times x minus 1 times x plus 1. Now, it might look like it's in a form where I can start canceling things, but because of that subtraction between those two sets of binomials, this numerator is not in factored form. So that means the first thing I have to do is FOIL or multiply out those two sets of binomials, then collect my like terms, factor, and then see if there's anything I can cancel. So that's quite a lot we still have left to do on this problem. So first I'm going to FOIL this. X times x is x squared. Outer is plus x, inner is plus x, last is plus 1, minus, because that's a subtraction, I'm going to put a parentheses there because I need to change all my signs after I do the multiplication. So again, I'm going to FOIL. First is x squared, outer is minus x, inner is minus 4x, and last is plus 4 over my common denominator of x minus 1 times x minus 1 times x plus 1. Okay, so now I'm going to, in the next step, change my signs behind the subtractions, collect my like terms here. So I have x squared plus 2x plus 1 minus x squared, and minus x minus 4x is minus 5x. I'll collect those two. That's minus 5x. Subtract a negative 5x, and it's plus 5x minus 4 over, I'm just going to say my LCD here. And let's extend that page a little bit more. Okay, so now I'm going to collect my like terms here. That gives me x squared minus x squared cancels out. 2x plus 5x is 7x. I used those, so I'll get rid of them. 1 minus 4 is minus 3 over, remember that LCD was x minus 1 times x minus 1 times x plus 1. Whoops, that's a 1 there. Okay, and now there's nothing that I can factor out of 7x minus 3, so I'm going to now write my final answer in its simplest form. There's nothing I can cancel, of course, so I have 7x minus 3 over x minus 1 squared times x plus 1, And that's my final answer. Okay, for number 20, once again I don't have a common denominator, and before I can figure out what it is, I need to factor each of these denominators to see what I already have in common. So I have for the first one a plus 2 over, I'm looking for what multiplies to 4 and adds to negative 4, which is negative 2 and negative 2. So that's a minus 2 times a minus 2, or you can write a minus 2 squared, minus a minus 3 over, that's the difference of squares, so it's a plus 2 times a minus 2. So looking at our LCD here, remember from each rational expression, I take all of my denominator factors. So I have a minus 2 squared. And in this one, I've already used the a minus 2, so I don't need to add that. It's over in the left-hand one, but I do need to add the a plus 2. So there's my LCD. So now I have to look at the first and the second fraction and see what part is missing. From my first fraction, what's missing is the a plus 2, so I'm going to multiply the top and bottom by a plus 2 times what I already have there, the a plus 2 over the a minus 2 squared. And for the next one, what's missing from my denominator is one of the a minus 2's, so I have a minus 3 over a plus 2 times a minus 2, and I'm going to multiply the top and bottom by the a minus 2. Remember, when I multiply the top and bottom by the same thing, I really multiplied by 1, so I haven't really changed the value of that fraction. So let's extend a little bit here, give us a little bit of space, and now I am going to multiply the numerators. A plus 2 times a plus 2 gives me, I'm going to FOIL that out, that's a squared, outer is plus 2a and inner is plus 2a, so that's plus 4a, and 2 times 2 for last is plus 4. Minus, you notice this time that I'm going ahead and collecting my like terms as I FOIL. If you need to go write it on scrap paper to get that polynomial, feel free to do that. Now I'm going to draw parentheses here because I'm subtracting the product I get when I FOIL those two binomials. So first, a times a is a squared, outer is minus 2a and inner is minus 3a, which gives me minus 5a, and last is plus 6 over my common denominator of a plus 2 times a minus 2 squared. So now I'm going to change the signs of the things behind the subtraction sign. And that gives me a squared plus 4a plus 4 minus a squared plus 5a minus 6 all over. Let's for a second just say the LCD. Extend the page a little bit. And now I'm going to collect my like terms. The a squareds cancel because one's positive and one's negative. 4a plus 5a is 9a. So I've used those. I always like to cancel out so I don't miss something. 4 minus 6 is minus 2 over. Remember that LCD was a plus 2 times a minus 2 squared. And there are no factors in common in my numerator. There's no GCF there, nothing I can factor out, so that means that's my final answer. There's nothing I can cancel with the bottom since I wasn't able to factor anything on the top. And that's my final answer for that problem.